Hey guys, today's our fourth set of notes, which we're going to go into balancing equations. I will tell you, I'm super excited for this set of notes because this is actually something I find really fun. It's kind of like a puzzle. You're trying to figure out what numbers fit where, and I'll totally admit, you guys are fully aware that I'm a complete dork, but I actually have games of this on my phone where I'm seeing how fast I can balance these equations. So, because we're looking at chemical equations, we need to remind ourselves what a chemical change means. A chemical change means that new compounds are created. So this is something different than just a physical change, which would be like a change of state or changing the appearance of something, like taking a piece of paper and cutting it. A chemical change gives you a whole new chemical at the end. The law of conservation of mass is something you looked at actually in grade 8. And it means that mass is not created or destroyed. Atoms are just rearranged, which means the elements you start with are the elements you finish with. It also means that the mass of the reactants is the same as the mass of the products. And remember, reactants are what you start with, products are what you end with. This also means that the number of each atom in the reactants has to be the same as the number of each atom in the products, because what you start with, you finish with. It's just rearranged. So if you could collect and measure all the exhaust from this car, you would find that the mass of the reactants, which is the gas plus O2, is equal to the mass of the exhaust that's coming out of your car, which is kind of cool when you think about it. So chemical equations can be written in different ways. You can have a word equation, like this one. Nitrogen monoxide plus oxygen gives us nitrogen dioxide. Or you can have it as a symbolic one. Nitrogen monoxide plus oxygen gives us nitrogen dioxide. So your assignment today will actually be taking these word equations and then writing out the symbolic equation. That's your end goal for today. So looking at these equations, they can look really complicated, but once you break it down, it's not so bad. So the little symbols underneath the different chemicals, let's see if we can change colors here. Right here, these are actually just the state of matter, which means it tells you which state that chemical is found. There are 4 different ones. There's aqueous, which means dissolved in water. There's S for solid, L for liquid, and G for gas. So if you look at this equation that we have, all of them are actually gas forms. You're actually mixing 2 different gases to get your new chemical. The numbers before the chemicals are called our coefficients. And this is just like in math when you're looking at algebra and you're looking at variables and stuff like that, and coefficients. But these numbers right here are called coefficients. And this oxygen, there's nothing in front of it, but that means something too. When there's nothing written down, what do we always assume in science? We always assume that it means 1. So here, this shows us the ratio that we have 2 nitrogen monoxides for every 1 oxygen, and that will give us 2 nitrogen dioxides. And if we listed these out, let me rewrite it, NO plus O2, NO2. If we listed these out, we only have 2 elements on the side. We have nitrogen and we have our oxygen. And on this side, it's the same thing. We have nitrogen and we have oxygen. Well, how many nitrogen do we have on this side? We have 1. How many oxygen? Well, there's nothing written beside it, which means 1 here, but we have a 2 here. So how many do we have in all? 1 plus 2 gives us 3. Now we look on this side, 1, and we have 2 oxygens. Well, we want these to be equal. We have 1 nitrogen, that's fine, but we have 3 oxygens and 2 oxygens. That doesn't work. And even if we started multiplying this by 2, it still wouldn't work because this number is the bigger one. So what we need to do is take this number and times it by 2. We can't change the subscripts. The only thing we can do is add a coefficient in front. So if I have 2 nitrogen dioxides, that changes my numbers. Instead of 1 nitrogen, now I have 2 nitrogens. Instead of 2 oxygens, now I have 4 oxygens. Now we look at the other side. Nitrogen, 1, well we need 2, so I'm going to throw a 2 in front of there. And let's see, 2 times 1, that gives us 2. 2 times 1 plus 2, that gives us 4. Well, now I have 2 nitrogens and 4 oxygens, which means this is my balanced equation, which we already knew from over here, but that's how we figure it out. Okay, so often you'll be given a word equation and you'll have to give me a balanced one. In this one, I give you both the skeleton equation, which is this one right here, which means that the formula is written down, but it's unbalanced. And I give you the word equation. So potassium metal, so just K, plus oxygen gas, which is O2, gives us potassium oxide. Okay, so again, we draw a line so that we separate the products from the reactants, and then we list the different elements. I always like to list my metals first and my oxygen as my very last thing. This is because that's the order that you'll balance everything in. This one's really easy. There's only potassium and oxygen. This side again, it'll be potassium and oxygen. With the products and the reactants, I try and list them in the same order just to make it easier when I'm balancing. So potassium, there's no number here, so it has to be 1. Oxygen, we have 2. Potassium, we have 2. Oxygen, we have 1. Okay, so let's try it out. This is something you really need to do in pencil and not in pen because sometimes you'll get it wrong. Okay, so if we look, we have 2 potassium on this side and 1 potassium on this side. So we need to multiply that by 2. That changes this to 2. Now we have 2 to 2. Oh, but our oxygen, we have 2 of these and only 1 of these, which means I have to multiply this by 2. But that makes it a little more complicated, doesn't it? Because not only have I changed our oxygen, we have 2 oxygen now, but I've also changed our potassium. Instead of having just 2 potassium, we now have 4. Well, now it's not balanced again. Okay, so if I have 4 here and only 2 here, what I need to do is I need to change this 2 to 4. See why the pencil comes in handy? So if I change that to a 4, this number goes from our original 1 potassium up to 4 potassium. So we have 4 potassium, 2 oxygen, 2 oxygen. This is our balanced equation, which on another worksheet you may have to just fill in the blanks. And remember, even though I didn't write anything for oxygen, I would still give you a mark because leaving this blank is telling me that you think that that number is a 1. So even leaving something blank will still either gain you a mark or cost you a mark depending if it's right. Okay, So writing and balancing equations. A skeleton equation shows only the formulas. So this, like potassium plus oxygen, gives us our potassium oxide, but it's not balanced. A balanced chemical equation shows us our coefficients that make sure that we have the same number of each element on each side. For today's assignment, you'll be given the word equation. You'll have to write me a skeleton equation, and then you'll have to give me a balanced equation. And just to give you a heads up, you do have a quiz on this next week where you're going to be doing the same thing. Okay, so diatomics. This is something from grade 9. Diatomics are very special. These guys are never found by themselves. They're always found with a pair. We talked about this the other day. So it's hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. So other than hydrogen, it is our 7 on the periodic table. These guys, when you see oxygen gas, hydrogen gas, nitrogen gas, anything like that, you won't find it as just hydrogen. You'll find it as H2. It's not oxygen gas, isn't O, it's O2. So these guys you'll never find by themselves. You will find them when by themselves when they're attached to something else. So H2O, oxygen there's not 2 oxygens, but it's not by itself because it's connected to the hydrogens. So you just have to be careful with that when you have them by themselves, they're going to be in pairs. So let's go over some examples. So, first thing we do, draw our line. Second thing we do, write our elements. So we have lithium and bromine. Like I said before, I try and list out my metals first. On the reactant side, I'm going to list them in the same order, just to make it easier to see. Now we start to count. We have lithium 2, so we have 2 of them. Bromine 2, so we have 2 of them. Lithium nothing, so we have 1. Bromine nothing, so we have 1. So lithium, I have 2 on this side, only 1 on this side, so what coefficient should I be putting? A 2. So once I've done that, let's rebalance. Now this side the products haven't changed at all, but the reactants have. So now we have 2 lithium, 2 bromine. Well, we have 2 and 2, which means we're done. We're even. Not so bad. Let's try a different one. First thing we do, draw our line. This one's a little different. It's trying to throw you off because it has one thing that's splitting into 2 things. So metals first, Na, and then our nonmetal N, Na, and our nonmetal nitrogen. As you can see, nitrogen is one of our diatomics, which is why it's found as N2 over here. Okay, let's see how many we have. Sodium, we have 1. Nitrogen, we have 3. Sodium, we have 1. Nitrogen, we have 2. So right now our NAs are balanced, but that's not going to stay that way. Now let's look at here. We have 3 nitrogens on this side and 2 nitrogens on this side. So what we want to do is we want to multiply this by 2 to give us an even number, because we can't do anything with a 2 unless it's even. So 2 times 3, we'll put 2 here. Now we have 2 NAs and 6 nitrogens. Okay, well if we have 2 sodiums, we need 2 sodiums on this side. If we have 6 nitrogens in the products, we need 6 on this side, so we have to times it by 3. So now we have 2 sodiums, 6 nitrogens, 2 sodiums, 6 nitrogens. So our coefficients ended up being 2, 2, and 3. Do you kind of see how this is a puzzle that you're trying to figure out what things work the best? And it does take a couple attempts sometimes. Okay, let's try this one. I'm going to rewrite it so that we have more room to work. So C2H6 plus O2 becomes CO2 plus H2O. First thing we do, draw our line. Now we list them out. So hydrogen and oxygen are always the two we're going to do last, oxygen at the very, very last. So even though there are no metals here, we're going to start with carbon, then we're going to go to hydrogen, and then we're going to go to oxygen. And remember, we keep the same order on the other side. So we have 2 carbon, 6 hydrogen, 2 oxygen. Now this one's a little tricky again because we have oxygen in 2 spots, but we'll get to that when we get there. There's 1 carbon, 2 hydrogen, we have 2 oxygen over here and 1 over here, which means we have 3 in all. Okay, let's start balancing. So we have 2 carbon, 1 carbon. So right away I'm going to throw a 2 up there. Let's see what that's changed. 2, and now I have 2 oxygen times 2, which is 4, plus our 1 over here. That gives me 5. We have 6 hydrogen over here, but we only have 2 over here. So what do we have to multiply this 2 by to give us 6? 3. So 3 times 2 gives us 6. And now we have to count our oxygens again. So 2 times 2 is 4. 3 times 1 is 3. So that's 7 oxygens. Okay, so our carbons are balanced still, our hydrogens are balanced, but now we have 2 oxygens and 7. How can we make 2 into 7? Seems like a tricky question, huh? Well, there's a couple ways we can do this. One is using fractions. So what could we multiply 2 by to get 7? Well, we'd have to multiply it by 3.5. And what's 3.5 in a fraction? So it's going to be over 2. And it's going to be 3 times 2 is 6, plus 1/2 is 7. So we'd actually put it 7 over 2. So now if we did that, 2 times 3.5, well, that would give us 7. So now we have 2 carbons, 6 hydrogen, 6 hydrogen, 7 oxygen, 7 oxygen. So some people leave it like this with a fraction. The other thing you can do is then you would actually have to multiply the entire equation by this number 2 to get rid of it. So we'd end up with 2C2H6 plus 7O2 gives me 4CO2 plus 6H2O. And all I did was multiply every single coefficient by 2. Which, remember, this blank one means it's a 1. So 1 times 2 gives us 2. I'll accept either way. It doesn't really matter which way you want to use it. Okay, let's see this next one. Our last one, actually. MgClO4 2 plus sodium gives us NaClO4 plus Mg. So this one has our polyatomics in it. There are two ways that we can do this. We can split up the polyatomic. But if you look, we have ClO4 here and ClO4 here, and we don't have any other oxygens or chlorines on either side, which means we can actually keep these two together. But the first thing we do, draw a line. So we have Mg, Na, and then I'll put my polyatomic, ClO4. This only works because the elements are kept together on both sides. If there's any other oxygen or any other chlorine in this equation, I couldn't do it this way. G, Na, ClO4. Okay, now let's start counting. We have 1 magnesium on the side, we have 2 of our chlorates, and we have 1 of our sodium. This side we have 1 sodium, 1 of our polyatomic, and 1 of our magnesium. So the big difference, oh, I made a mistake. We don't have 4 of these, we have 2. The only difference between these, the magnesiums are balanced, the sodiums are balanced, it's our polyatomic that's not balanced. So now we have to make this number into a 2. So we multiply that by 2. Let's see what that changes. Well, now we have 2 sodium, and we have 2 of our polyatomic. Okay. Well, 1, 1, 1, 2. Okay, now we have to change this. So if we multiply that by 2, let's see what it changes. Well, it only changes our sodium. 1 magnesium, 1 magnesium. 2 sodium, 2 sodium, 2 of our polyatomic, 2 of our polyatomic. This is our balanced equation. So even though this looked a lot more complicated, it's not that bad. We could have done this the exact same way, but split up our polyatomic. So we could have written out Mg, Na, Cl, and O. And done the exact same thing. 1, 1, there's one of, no, sorry, chlorine. There's 1 in the brackets, but there's 2 of the brackets, so there's 2. There's 4 oxygen inside the brackets and 2 of the brackets, so it's 8. 1, 1. There's only 1 chlorine and 1 oxygen, or sorry, 4 oxygen. So we look 1, 1, 1, 1, 2, 1. Well, 2, 1, we want to multiply this side by 2, which we did. That will change this to 2, this to 2, and this to 8. Then we had to go back here. We only have 1 of our sodium, and we need 2. So we multiplied that by 2. That gave us 2, and now we're balanced. So as you can see, this was the exact same process. It's just that it was a lot quicker when we're able to keep the polyatomic together. I am linking a couple of videos on the description below of just other videos of people explaining how to do this. Your assignment is already posted on my Google Drive, and if you have any questions, please let me know. I have also added the due dates for all the assignments on my calendar on my website, so please check that to see when the assignments are due. I'm trying to make due dates on Tuesdays and Thursdays. Hope you guys are doing well, and I'll talk to you this week. Bye.